Let's get ready to nail every single question on the CCNA exam when it comes to these successors and feasible successors, which is going to be a major topic, not only in EIGRP, but for your exam. We've got EIGRP and we've got three tables in there. We've got the route table, which contains the best routes to the destinations. You know, it makes perfect sense. We've seen static routing tables and OSPF routing tables in our overall IP route table in the last couple of sections. So, you know, we've seen those. The neighbor table, you know, where information about the neighbors is kept, no big secret there. And certainly while the terminology is different, you know, it's going to look a lot like OSPF and the neighbor table there. Then the topology table, that's a new one. That's where the best routes are also kept, along with valid but less desirable routes to those same destinations. Valid but less desirable. That's about as vague as it gets. Why are they valid and why are they less desirable? We're coming back to that. As a matter of fact, we're coming back to it once on the same screen because I mentioned again, you know, as EIGRP learns about the network, it keeps the best routes along with all loop-free valid routes in the topology table. So there's another way to describe these other routes, loop-free and valid. Now about those other routes, those backup routes, EIGRP calculates those routes before a failure occurs. We love that. You know, we lose a route and we go, hey, we got another one in the topology table, let's just stick that in there. And that makes convergence after a failure with EIGRP just lightning fast. Now, the EIGRP term for the best route is successor. Any valid alternate route is referred to as the feasible successor. So now we've got three different ways that I have described this feasible successor. I've described it as valid but less desirable. I've described it as loop-free and valid, and I've described it as valid and alternate. So the word valid keeps popping up here, but you know, what makes a route valid but less desirable? Well, in networking, as in life so often, we just have to ask the right question, and in this case, that question is the EIGRP feasible successor question, which is technically called the feasible successor condition. Now, the condition or the question is the router asking itself, is the reported distance for this route lower than the feasible distance? Cleared that right up, right? Well, you know, that kind of leads us to two more questions. What the heck is a feasible distance and what's a reported distance? I have seen some incredibly convoluted explanations, some of the most convoluted explanations in the history of history about these two terms. I'm going to cut right through all that and just tell you exactly what they are, okay? It's very, very straightforward. The feasible distance is the local router's metric for a path. The reported distance is the next hop router's metric for this same path. That's it. A good way to remember it, since you're on the local router, of course, and you usually think in terms of the local router, it's like the reported distance is what was reported from another router. That's the way I've always remembered it, and of course in this case that would be the next hop router. The feasible distance, of course, is the one that's left, and that's the local router's metric for a path. Now let's take our first look at the EIGRP topology table and use it to see what's going on with this whole FD and RD thing. And I ran show IP EIGRP topology to get this output, and we've got plenty of live labs coming up, but I'm going to have a couple of walkthroughs here with the feasible successor condition, 3 or 4 of them actually. So in a minute or so you might want to pause the video and grab something to write with. Now the first number in those parens, 2195456, that is the route's feasible distance. That is the metric of the route from the local router to the destination network. We got that down. The second number, 281600, is the route's reported distance. This is the metric from the next hop router to the destination network. I know I'm hitting you over the head with that right now. You can thank me later though. Now, in this particular case, the feasible distance of both routes is exactly the same, and that's why we see the phrase two successors in the middle of that top line. We got the letter P followed by a network followed by two successors, and then feasible distance is 2195456. When the feasible distance of the routes is exactly the same, they're both going to be marked as successors. And the load will be balanced over those two links. Hintity hint hint. That's load balancing, of course, and we've got two different kinds with the EIGRP, and we've got some live labs on that coming up. But that is going to happen by itself only when the FD is exactly the same. Just a quick word here before we continue too. When you're comparing these values, Just make sure that you take a second look at those numbers in the paren, because it's really easy when you're dealing with 6 and 7 and 8 and 9 and 10 digit numbers to miss a digit when you're comparing two on an exam. And you'll see a huge EIGRP metrics. I mean, this is in a practice lab. It's a nice practice lab, but it's not exactly an enterprise network. And our FDs are already in the 7 digits, so you can imagine how big EIGRP metrics can get. Now, these distances are also used by EIGRP to determine what routes can be feasible successors. And now we're going to look at two routes to the 3 network /8. We've got the letter P again. That seems to be coming up a lot. We've got 3000/8, one successor, and then feasible distance is 229.7856. Now, we only have one successor here. We know it's the top route since the FD of that route is the FD named in the top line. I also bolded it to make it even more obvious. Now, the question is, can the route through 172.12.123.2 be a feasible successor? And let's just go right back to that particular screen we're looking at. Can this second route be a feasible successor? And we're looking at a reported distance of 409,600 versus a feasible distance of 229.7856. I'll fix that RD number, but it would still be less. So the route through 172.12.123.2 is indeed a feasible successor. Now, that was a little bit of a cheat, I admit, because the EIGRP topology table holds only successor and feasible successors. You're not going to see every single potential route in the topology table. If it is not a successor or a feasible successor, you're not going to see them in there. So EIGRP has already done the work there. But I would personally be more than ready to determine successor and feasible successor routes on your NA exam by just being given the metrics of the paths. And that's what we're going to do next. We're going to do 2 walkthroughs here, and one of them with smaller numbers and one with slightly larger ones, and we'll do that on the very next video. I'll see you there.